Which of the following are tests used to determine a mineral's identification? Back with our mineral tests, we had the mineral kits when we did the lab, and we looked at things like hardness, streak, etc. So let's look at these. The hardness was the first one, and obviously that's a mineral test. That's from the Mohs hardness scale, where we would take and see. We didn't have the full kits to do with all the different minerals, but we had glass and nail, because glass has a hardness of 5.5. So if the mineral scratched the glass, we knew it was harder than 5.5, and if it didn't scratch the glass, we knew it was less than 5.5. But there are actual kits out there that have all of these minerals in there. And so you would take something like apatite first and see if the apatite would scratch it instead of using the glass. And then if it did, if the apatite scratched it, we knew it would be one of these softer ones, or would be the hardness scale. And so you'd try calcite and see if that would scratch it. And if calcite scratched it, I knew that the hardness would be like a 1 or a 2. So you just narrow it down based upon the Mohs hardness scale. Foliation wasn't a test. Remember, foliation is a metamorphic rock term, whether you can see those banded lines in it or not. Texture is not a term that we use for minerals. Again, I would say don't get minerals and rocks confused. Texture is something. Texture and composition is what we use for igneous rocks. Texture being the grain size, whether it has large grains or small grains that you can't see. And also composition would be whether it's felsic or mafic. So this would not be a term we associate with minerals. Cleavage would be, though. Cleavage is how, when it breaks apart, if it keeps nice flat planes like mica right here, this is the one that peels apart into nice flat flakes. And so on the flat sides, that would be considered one cleavage plane right there. There's not cleavage where it tears around here. These are not flat edges, but the top and bottom are. Pyrite over here, don't get crystal faces and cleavage mixed up. This is not cleavage. This is how a crystal face forms. The trick is when I hit this with a hammer, when it breaks, pyrite won't keep those nice flat faces. When I tear mica, it does keep the flat tops and bottoms. So cleavage is when you break it, how does it keep it? But it is a mineral test. Color is a test. It's not a good test, but it is a test. Pyrite is one of the first things that jumps out at you, is that gold color. So it would be considered a test, but it's not the best test. We don't want to depend on it. Things like quartz can come in dozens and dozens of colors, and so it's not something that we want to depend on. Roundness, that's not a test. Specific gravity, that actually is a test. Specific gravity, think of the same thing as density. Every mineral has unique densities, and so by taking the density of a sample, for instance, if you had something that had a density of about 19.5 grams per cubic centimeter, you would know, hey, it's probably gold. That's a very dense material. And so density is something you can use. In specific gravity, just think of them as being the same thing. The parent rock, again, that's a metamorphic term, so we're not going to check that. And streak, well, here's the streak test down here. It's the true color that it leaves behind in powdered form when you grind it against a plate, a ceramic plate, and some of that material powders up on there. So, and this is one of the tests you use for fake gold, for fool's gold. Real gold, if you drag it, will leave a gold streak on this plate, but pyrite leaves a dark greenish black streak on the plate.